Hello everyone, in this video we'll be solving problem 28. Find the index of the first occurrence in a string. The problem statement is, given two strings needle and haystack, return the index of the first occurrence of needle in haystack, or else return -1. The problem statement is pretty straightforward. Let's look at example number 1. In haystack text, the needle which is sad appears at index 0. It's also there at the end, but we need to return the first occurrence, so our output will be 0. In example number 2, the haystack is LeetCode, but the needle is Leeto, which does not exist in the haystack text, so the output is -1. Let's switch to the whiteboard and discuss potential solutions. The simplest solution would be to run the iteration on the haystack string, and at every position we will check if the corresponding character in haystack text equals to the corresponding character on the needle. For example, if I start my iteration, so my hi pointer is 0, my needle pointer will also start at 0. I will check what is the corresponding value at hi of 0, which is L, and ni of 0 is also L. Is this equal? Yes. So we will start a nested iteration to compare the next character. So now next hi will be 1 and ni will also be 1. The corresponding values are e. They are still equal, so we'll continue the same nested iteration. So my hi will become 2 and so on and so forth. We'll continue to do that until all the characters in the needle stack are equal or available in the haystack text. If at any given point of time we get a no, we will jump out of the iteration and go back to the primary loop and start again. So at that point, my hi will be 1 and I will compare it against ni of 0. Couple of improvements that we can do is to only run the nested iteration until the length of needle. In this case, the length of needle is 5. When we are doing the nested iteration, we don't need to go deeper than 5 characters in, because there is no point going forward as the text will not be equal after that. When I am running the original for loop on this hi pointer, I can only run it until hi is less than or equal to h dot length minus n dot length. If there are 5 characters in the needle's text, I need to only run the for loop on hi pointer with hi pointer until this position. If I go any further, the total number of characters from this point on are 4 or less, which will never be equal to our needle text. So this is how we can optimize the solution. The time complexity of this solution is O of m by n, where m is the number of characters in the haystack text and n is the number of characters in the needle text, and our space complexity is O of 1, as we are not persisting anything. Let me show you how we can implement this using C#. Here is my C# solution. I start by checking if the needle.length is less than haystack.length. If it is greater, the needle text will never be able to fit into haystack. Then I start the for loop where I is equal to 0 until I is less than or equal to haystack.length minus needle.length. If the haystack.I or the character at I position in haystack text equals to needle.0, so that the starting character in needle text, if it is true, I'm recording the index in this result variable, which is returned at the end, and then I start the nested for loop only until needle.length. If at any given point of time the character in the haystack text is not equal to the character in the needle text, I reset the result variable to -1 and break out of the loop. After the for loop is complete, let's say the result is no longer -1, which means I have found needle present in the haystack text. I don't need to continue the iteration any further because we are only looking at the first position or the first index. So we'll break out of the first for loop. If this condition is not sufficed, we also need to check if the needle is equal to haystack, which means that both texts have the same value. If that's the case, we can simply return 0 without doing any iterations further. This solution, when submitted on LeetCode, beats 100% of the submissions made so far in terms of runtime complexity, and its memory utilization is 67%. I hope you were able to understand this solution and the explanation. The link to the source code is available in the description below. Feel free to check that out. And if you have any questions, do not hesitate in reaching out to me, and I will see you in the next one. Thank you.